we're going to talk about what do we mean by synthetic data, the educational context, the potential and limitations of synthetic data generation, and we're going to talk about a case study, the real-world impact on educational research, and future directions and some conclusions. And the very last slide contains all of the citations that we're talking about within this. So why do we need to think about synthetic data? We've got a huge privacy concern that is critical in our digital age, in the advancements of AI, because they rely heavily on data sets for training and development. Traditional methods of anonymization, while useful, often fall short in terms of privacy safeguarding of sensitive information. We're looking at, particularly in the pre-university context, where the personal identifier information is really important. This presentation explores synthetic data as a sort of innovation and alternative use to addressing key research questions. And so by examining the limitations and potentials, we aim to shed light on a path forward that balances both the technological progress with the ethical responsibilities. And I'm going to hand over to Ingunn for an introduction to synthetic data.
Thank you, Genevieve. So here we have at least one of the definitions that exist on synthetic data. It refers to the artificial generated data that replicates the statistical properties and patterns of real-world data sets without exposing sensitive or personally identifiable information. And as you said, this is or can be quite an innovative solution for addressing privacy concerns in data-driven research, especially where real-world data privacy is a priority. So to understand its potential, but of course also its limitations, we need to examine what synthetic data is, but also the methods that we use to generate it. And here we see different generation methods. For instance, decision trees, deep learning algorithms, generative adversarial networks, GANs, and statistical modeling. And each of these approaches has their own unique strengths. For instance, decision trees and statistical models, they are often used to capture relatively simple relationships within data. On the other hand, we have deep learning techniques and GANs, which are typically employed for more complex data. They can even reproduce high-dimensional patterns, and they are effective for generating sophisticated and realistic data sets by modeling complex data distributions. And also we have GDPR, and in the educational sector, where sensitive student data is regulated by privacy laws, such as the AI Act and GDPR, synthetic data offers a way to facilitate research, but still while protecting privacy. And the use of synthetic data provides additional layers of protection and privacy for educational research populations. And we do have this Article 89, because this is interesting. 89 specifically allows for the processing of personal data for research purposes, provided that appropriate safeguards are in place, such as data minimization, anonymization, to protect individual rights and freedoms. And now we can move on to the education. Yes. In higher education, institutions handle vast amounts of sensitive data, including academic, behavioral, and personal information, which underscores the importance of privacy in data use. However, the need for privacy is even more pronounced in pre-university research, where student populations are often minors and require additional protections. So synthetic data has valuable applications in both pre-university and university level. Students can work with data sets that are statistically like real-world data without encountering privacy issues. And if we look at the different applications, as we see here on the slide, we have student performance models. They support predictive algorithms for academic success without compromising privacy. Further, behavioral pattern analysis. They simulate student engagement and interaction trends for better interventions. Further, curriculum optimization. They help design tailored programs while maintaining privacy standards and also resource allocation. Models equitable distribution or resources like staffing or funding. And we will mention some of the research benefits here briefly. Cross-institutional collaboration. This enables secure data sharing across institutions without legal or any ethical barriers. Also, reproducibility provides privacy and compliant data sets for replicating studies and validating results. And finally, we have standardized benchmarks, supports consistent testing of AI models with privacy-safe uniform data sets. And now I will give the word back to you, Genevieve, to take us to the more empirical part.
So over the next couple of slides, I'm going to talk about a current study that we're doing. So there's one part of the study, which is the development of an augmented reality performance experience that uses synthetic biometrics data. This uses brainwave and motion caption data. And the second part, more interestingly for this particular symposium, is the development of the same processes, but then transferred into educational context. So, and it's important to note there are kind of several ways that you can actually develop synthetic data. And what we're using in this particular project is synthetic data or synthesis, which is the process, from real world data. And then there's synthesis without data, but that means that the developer or the researcher needs to know the full characteristics, attributes of the data set in order for it to be statistically reliable. And then there is a sort of hybrid of the two. And the reason why that we're interested in synthetic data sets is, as Ingunn mentioned in terms of the broader context, is this data sharing without exposure, is that in terms of developing synthetic data sets for classroom use, and I'm particularly looking at pre-university settings, so students who are in grade 10 to 13, so just before university, it allows them to think about the computational aspects as well as the data protection aspects. And if they were developing sort of synthetic data on them for themselves, then it would also allow this anonymity to be maintained. And the other interesting things in terms of actually when you do the processing part is in the post-processing, once you've done the synthesis, you can do modifications to the data set called augmentations, refinement, or modification. And this allows you to often remove or keep in outliers. And also it's really good for actually removing bias. One of the things that we want to maintain throughout this particular project is that these data sets were built on real world human data. Even if it isn't the data itself, it's still the attributes. And we must not dehumanize these synthetic data sets into just bits and bytes. And interesting things in terms of regulatory compliance across the board from the EU AI Act, as of February 2025, it comes into force that all organizations must ensure to their best of extent the sufficient level of AI literacy among staff and others who operate and or use AI systems on their behalf. And that's February next year. So this is something that we should be mindful of when we're teaching our students, and particularly in a computing education setting. So the implementations. So one of the things that are quite interesting in terms of this and that are particularly challenging is both the computational load of these things, the technical requirements, and also the programming. So for what we're using, both for our generation in the AI, in the augmented reality product and in the education, is that we're using Google's Colab, which is a Jupyter notebook, and it uses MIT's Synth Data Vault Python library. And we particularly chose Python for its global use within education and industry. There's the Colab notebook actually contains code, anonymized data sets, which is my personal biometric data done from ballet classes and video production while wearing my EEG headset. So they both have the motion capture and they have the brainwave data. So we're testing this with a group of a very small group of undergraduate students, computer science, and that's for clarity and use of the notebook. And then in June, I'm running this again with a set of PGC, so pre-university, so pre-service trainee teachers in London, and they're going to look at the educational implementations and curriculum alignment. And so one of the things that we want to look at is the evaluation of this tool from a computing curriculum. Does it actually match and fit in, and can they do this? And then also the evaluation in terms of, is this actually helping them understand AI in a broader context, and specifically looking at data ethics and bias? So one of the biggest challenges is, can we look at this idea of mitigation or preservation of data bias within the set? And then in terms of its real world impact, again, who knows? But I think it's a really interesting tool that we can kind of go further down. And this isn't just about generating the synthetic data, it's about understanding the process and what happens with that. It's for collaboration in terms of, from a student perspective, it allows them in the context of our study, to generate synthetic motion capture data. And therefore, they can then create their own rigged characters and put them in a synthetic world or an augmented reality world. We're actually getting them to build the world, unlike what Mairead was talking about, these ideas of just uploading an image and the AI can generate a synthetic world. We actually want the students to understand, the actual process of generating augmented reality and XR worlds. And it also provides them with the computational pathway to explore data ethics, AI, and the programming skills. With a really big caveat that we're exposing educators and learning to this privacy first or privacy by design methodologies. So we might be looking at things like zero trust methodologies from Microsoft to other sort of the IEEE's neuroethics for education frameworks, etc. So where do we go next? Who knows? It's quite exciting, actually. So with all of these things, the one really interesting thing about generating synthetic data, you do not need a lot of data to generate the synthetic data. And it allows sort of educators, students to do these kind of sandbox testing, also without compromising safety and privacy of the individuals. I would say, though, we do not expect any of our motion capture synthetic data to work. It's really, really difficult to generate synthetic data from very fast motion capture data. And then the other thing that we're interested in terms of integration and policy is like there is still some way to go in terms of recommendations of cross-border data compliance in terms of synthetic data. So just to wrap up, so again, synthetic data has the potential to open doors to research and educational development beyond just generating a set, but actually understanding how it works. It also allows you to generate sort of this idea of a synthetic versus private data set, and also in terms of balancing between privacy, reducibility, and data sharing. There is a need for challenging and being mindful of data accuracy, technical, and bias within these data sets. So it's an attractive tool for researchers and educators, but we still need to think about where we need to go next. Thank you.
Excellent. Thank you so much, both. I'm stepping in as a moderator as Constance is dealing with some late registrations happening on Eventbrite right now. Thank you very much. As I tell all the speakers, imagine rapturous applauses. Yeah, being a webinar, we don't have that. So, any questions for our speakers? I'm monitoring here the open chat. Do you think so? It's the Q&A. Apologies, not the chat. Sadly, the chat is not enabled. Any question? Otherwise, I do have a lot of questions, but one that comes directly to mind, as you said, this is such an incredible thing to work with and think about for both educators and researchers. But if we think about educators in their daily activities, for example, how do you think they could engage with this and kind of make use of or learn from this topic? What would be a kind of a consequence for educators in their day-to-day?
Well, from a computing educator, you actually do a lot with data sets. So from my work when I was at a sort of pre-university, I'm now a lecturer doing sort of in digital media. So we look at also lots of data sets there. So one of the things that's really interesting is that you can't modify, you can't interrogate like simple data sets in the same way a very large one. So what you can do when you're dealing with large data sets, there are public data sets that you can use, but then again, there's still humans behind this, poverty data, weather data. And obviously what we want to talk about is them generating this data, understanding that they have a human behind the data points. And this is probably more in medical research that I find that the humans lost somewhat in there. And then the other challenge that they have, but I think is actually quite fun, is where the immersive learning is going with this.
Right.
So, and that is from every subject, not just computing. So I think it's really interesting. And again, taking it out of its context of computer science and actually the applied science of computing. So that we come more to more this computational social science view of it. But again, if you want to generate really statistically sensitive data that will allow you to manipulate and test hypothesis, I think there's a really good, interesting way that they can use it there. But that's just
Right.
off the top of my head. I'm sure there's a million other
No,
ways
I
that
mean,
you could use it.
I think, and I'm thinking here, you know, in terms of Ingunn and the collaboration we have ongoing on kind of creativity learning and tech, and now AI
Yes.
in particular, how useful and interesting would it be to use this, you know, to generate, yeah, exactly, new ideas as well. Ingunn, do you have anything to add on this?
No, but I was thinking, but this is a question more than a comment actually. What is the biggest promise with synthetic data?
Right.
Ooh.
And here we go.
Oh.
In education, we can restrict
Yeah,
it.
So for me, the promise is getting under the hood,
Yeah.
as the phrase goes. I think by allowing students to, and actually the code's actually not that complex, interestingly. It doesn't feel.
You showed, well, maybe we don't have time for you to show, but it was so.
That's what we keep for next year's edition, or maybe even before that, thankfully, because we do have events through
So
the
this
year.
is what it looks like.
Oh,
And there
great.
you just load the code. I mean, obviously it's anonymized, so it's really not complex.
Even I'm
Because
learning. Like,
so and again, what we're using is a very simple single table version. What we have to use for the augmented reality is a multi-time series one, because of the speed of the frames per second that we have on the motion capture data. So it's a little bit more challenging what we're doing for the augmented reality piece versus what we've translated into educational purposes.
Excellent. Excellent. Thank you both so much.